So in this video we're going to look at rates of reaction, and we're specifically going to look at the difference between the average rate and the instantaneous rate and how they can be calculated. So our learning intention is to differentiate between average and instantaneous rate and to complete calculations on instantaneous rate. So before we actually look at average and instantaneous rate, it's important to think back to your junior cycle and the experiments that we do in junior cycle. We should ask ourselves, do we think that we're finding the average rate or the instantaneous rate in these experiments? Now the answer is that we're actually finding both, because we find the instantaneous rate throughout the experiment and we can find the average rate at the end. So this brings me to my two definitions that I need to know for this video, the average rate and the instantaneous rate. So the definition for the average rate is the average rate of reaction is the appearance of a product over a specific time interval. So time interval is the key part there. The instantaneous rate of a reaction is the rate of the reaction at a particular instant in time. So that is the key difference. The average rate is a specific time interval, but instantaneous rate is at an instant or a specific moment in time. So as I've said, the instantaneous rate of a reaction is the rate of the reaction at a particular instant in time. So how can we calculate this? So when we're asked to calculate the instantaneous rate, usually beforehand you'll be asked to draw a graph of the amount of product versus the time. Once you have that, always draw a tangent line at the point X. So a tangent is a line that touches the graph at one point only. Once you have your tangent drawn, you should measure the slope. So the slope is the length of the vertical over the length of the horizontal, or you may be more familiar with the formula, the rise over the run. And this is the formula that I will use when I'm doing the calculation on the next few slides. And once you calculate the slope is the instantaneous rate. So it's important to remember that when you calculate the slope, that is equal to your instantaneous rate. So let's go through an example, and here we have a graph showing the production of oxygen, and we can clearly see that we have the amount of our product, or the volume, on the y-axis and the time taken on the x-axis. We can clearly see that our graph has our units labelled as well, which is extremely important. We can also see from the line of the graph that the reaction has kind of come to completion around this point here because the graph has flattened, and we've discussed that in our video on the production of our oxygen experiment. So here the question says to find the instantaneous rate at 1 minute. So 1 minute is 60 seconds, and that is at this point here. So what I must do is I must draw a tangent at our point 60 seconds, and as you can see I have that done here now. So if we follow our steps, once you draw the tangent you need to find the slope of the graph, and to find the slope of the graph we do the rise over the run. So I'm going to do the rise over the run, and I can clearly see here from my graph that my rise is approximately 55 and that my run is approximately going from 50 to about 110, so it's probably just around 60. So I know that the slope of my graph is the rise over the run, because that's my formula, and that's equal to the rise, which is 55, and the run, which is 60. So when you do 55 divided by 60, we get a rate of 0.91 centimeters cubed per second. So that means exactly at this point here, at 1 minute, we have produced 0.19 centimeters cubed per second. So let's try another example here. And we can see from this graph that we're looking at the production of hydrogen gas, where the volume of hydrogen gas in centimeters cubed is on the y-axis and the time in seconds is on the x-axis. And we have a lovely line drawn in here, and we can see that the graph is quite steep at the start, so we're producing a large volume of our hydrogen gas at the start, but as the time proceeds this graph starts to level off, which means the reaction is coming to completion. So specifically along here with these last 3 points, we could say that the reaction has gone to completion because the graph has now plateaued off. So the question asks us to find the instantaneous rate at 5 minutes. Now, 5 minutes is in the question, but our graph shows the x-axis in seconds. So it's good practice to convert the 5 minutes into seconds, and I know that 5 minutes in seconds is 300 seconds. So I need to go and draw a tangent to the curve at 300 seconds, which is here where I've just marked my yellow mark. So once you have the tangent drawn, you need to measure the slope of the tangent. So to measure the slope of the tangent, I'm going to do the rise over the run. So I can clearly see that my rise starts at about 52 and finishes at 66. So that means my rise is 14. And my run here starts at 100 and it finishes down here at about 420. So I know that the run there is 320. So I know that if I have the rise over the run, that gives me the slope, and that the slope is the instantaneous rate. So my rise is 14 and my run is 320. So that means the instantaneous rate at 5 minutes, or the volume that is produced at exactly 5 minutes, is 0.04375 centimeters cubed per second. So if you want to go and practice more examples on instantaneous rate, you can check out the exam papers section of the website, where I have loads of exam papers put up there with instantaneous rate on it. Or you can also try the quiz that I've created on this topic, as it contains a question based on instantaneous rate. That's it for this video. Have a read over the learning intentions to make sure you understand everything we've gone through.